Hello and welcome everyone. Thank you very much for being here. My name is Sumeet Chopra, and the topic of my presentation is message-driven microservices using Spring and Solace. I will like to first start with an overview on the messaging concepts. Then I'll speak about the framework, Spring Cloud Stream, Spring Cloud Function, and along with that, I'm going to showcase some sample programs with Solace Message Broker, and if the time permits, we'll do a quick demo as well. Just a brief about myself. I'm a software architect with 20 plus years of programming experience on Java and Scala. And I am currently have an extensive experience in digitizing government services with Digital Dubai Authority. My career span comprises of leading architecture, design, development, as well as delivery of large-scale enterprise solutions. So before I start with the messaging concepts, let's say that we have an e-commerce application and an order has been placed and on a website, and we need to call multiple services so as to process the order. So for example, you need to do the processing of the payment, you need to do the inventory update, you need to call the shipping, packaging services, and for a few number of orders, this is pretty fine. But as and when you have a lot of orders, or in terms of the scalability, this does not work fine. So what is the solution for that? So for that, let's say that we simply have our application alert the whole architecture that the order has been placed, an event has been called, and the whole technology stack would be published. And whoever wants to listen to those events will start consuming it and react accordingly. So with related to the same, one of the most important concept is the message. It is a data that is sent to a specific address. A message can be of two parts. It can be a header as well as the body. The header is the metadata of the data that has been transmitted, and the body is the data in the payload itself. The next is the event. In context of an application, an event, they are the records of something that has happened within the software system. So they are immutable because it has happened in the past. For an example, an order has been created. This is an event. The next is event stream. It is a continuous unbounded series of events, each containing the change of state. So the start of the stream would be somewhere before even the processing has begun, and the end would be sometime in the future. The next component is producer. Producer, it is a component that sends a message to the destination, and the receiver is a component that receives a message from the destination. And the last one is the channels. They are the logical addresses in the message brokers. Now, message-driven microservices means that the inter-service communication is being handled by the messaging middleware parties like Solace, Apache Kafka. The service communicate by publishing domain events across the event channels. Moving on to the next slide, I would like to share some info about Spring Cloud Stream. Now, Spring Cloud Stream is a framework that is used for creating an highly scalable message-driven applications that are connected by pluggable middleware. It is built on top of Spring Boot, Spring Integration, Spring Cloud, as well as Spring Messaging. You can build, test, deploy data-centric applications in isolation. And you can decouple the application responsibilities with an event-centric thinking. What that means is that, let's say, an event or a message has been produced. The downstream event consumers can react to those messages without even knowing where it originated from. The next is it also allows to apply message conversions for specific content types. And the last point is, which is very important, it provides an opinionated piece of code and gives you the complete power of Spring with respect to auto configuration, auto wiring, as well as dependency injection, and to communicate with the downstream message brokers. Moving on to the next slide are the core concepts behind Spring Cloud Stream. So one of them is the application model. The application model is a middleware, messaging middleware neutral that communicates with the external world by establishing connection between the destinations that are exposed by the external brokers, as well as the input-output channels of your application. And the next is the binder abstraction. The binder abstraction is an abstraction layer between your code and your message broker. So currently, Spring Cloud Stream provides multiple implementation of your binder abstraction. One of them is Solace. It provides for Apache Kafka. for Azure Event Hub, for RabbitMQ, and Google PubSub and Amazon Kinesis. So it automatically detects the binder implementation, which is found on the class path. Moving on to the next is the publish-subscribe communication model, which reduces the complexity between your producer and the consumers. What that means is that you can easily add any new service to your topology without actually affecting your external flow. The next point is the consumer group support. That is basically an ability to scale by creating multiple instances, which means that let's say your message needs to be, there's going to be a lot of processing involved and you need to scale. So consumer group support guarantees that your message will be delivered by handled by only one of the instance. And the last one, which is again an important concept, is the partitioning support, which helps in the stateful processing. So what stateful processing is, let's say you want to handle a message which are related in a particular instance. For example, you have an order with multiple line of items, and you want all your processing should be done by the line of items based on the order ID. So this can be achieved by using the partitioning support. And this partitioning support is currently supported by some of the binder implementations, not all of them. Moving on to the next is, whatever the concept, this is a diagrammatic representation of how the Spring Cloud Stream app would look like. It has an application layer, which is a code which creates the channel that can be input and output. And this does the boilerplate. The channel, basically, it represents a communication pipe between your application as well as to the messaging middleware, using the binder as implementation. And the binder handles a lot of boilerplate code. The next concept is Spring Cloud Function. Now, what Spring Cloud Function? It enables you to write Spring-enabled function once, and you can run them anywhere. You don't need to know that how the function is being called. Basically, what Spring Cloud Function enables you is that you can run it as an AWS Lambda as a serverless function, or you can also run on Google PubSub, and without changing any of the business logic. And it promotes business logics via functions. You can decouple the development lifecycle of a business logic from any specific runtime. What that means is the function can be exposed as a REST endpoint, it can be exposed as a message handler, or it can also be exposed as a stream processor. The next point is the functional programming model also gives you the benefit of function composition, where you can compose multiple functions into one and get the desired output. And the last important one, it embraces and it's built on top of 3 core functional interfaces. The first one is Java Util Function Supplier. That is the source or the publisher of the event. The next is the consumer, which is a sink and the subscriber of the event. And the last is a function, which is both the processor as well as consumes, process, and produces the event. So I'll just showcase some sample program now. OK, so this is, let's see. It's not updated. So this is a Maven POM, how it looks like, the project object model, where we have some of the convenient dependency descriptors that is included in the application. So we are going to include a Spring Cloud Starter Stream Solace, which will include all the messaging dependency, Spring Cloud Stream dependency, cloud, and boot as well. This is one of the class files, which is where we have the configuration of a function. So there are 2 functions over here. The very first function, it takes an input and gives me an output that is a string. There is some kind of a validation written over here so as to showcase how the error handling would work if there is a message that contains none. And there is another function called as a seed, and both of these functions are registered as a bean. Now, there is no orchestration defined over here. So this is purely a configuration, and as soon as the application will start, this will be registered in the bean. And let's see how it will be basically being triggered from outside. Now, this is triggered through there is a YAML file that is again a configuration of a fully functional Spring Cloud Stream application, which will produce and process the message. Now, we have a definition called as the same message name welcome and seed, which is the function composition. And the binder that I'm using over here is a Solace binder. So this is a configuration for the Solace broker. Now, Solace PubSub, it's a partner-maintained binder implementation for Spring Cloud Stream. And the environment, some of the attributes, key ones are the host as well as the message VPN. And this is where the binding is defined. The binding is basically Spring Cloud Stream will bind your composed function to the broker via the Solace binder implementation, like welcome set, input, and zero. Zeroth is the zeroth element, zeroth index of the function, and welcome set is the name of the composed function, and in is an input. So now whenever a message, it will start listening to the message of the broker that has been configured by the destination, and the destination points to that on the message broker itself. That is a queue that has been defined. The group is a welcome group, which is basically does the consumer group enterprise integration patterns, which will make sure that when you have multiple instances, only one of your instance will serve your message. And finally, once the processing is done, there is an output defined, again through a configuration to another message broker. So this whole is an opinionated way of programming and doing it through a configuration base. And there are some other configurations for the error handling. Now, this is how the error handler is done. This is basically, I'm registering a listener over here for error handling. In case you don't have any error handler, you go to the global error channel. But if you have defined an error handler, then you can use one of the component of Spring Cloud Stream, which is a stream bridge, where you can dynamically publish onto topics. So there might be some use case for you where you might write a strategy, and based on the type of the processed output, you might need to publish or spit out to a dynamic topic. That's how you can achieve it using this component, stream bridge. I'll just quickly go through the demo now. So I have a local instance of Solace running on my Docker machine. I'll connect to the default VPN. So these are the queues which are been defined. So there is an input queue where I'm going to publish a message, and it will be processed by my application. And there is an error queue as well, because I've used a custom mechanism of error handling. There is a try me app that it provides. Let me connect to it. I'll connect to the queue. Input. And I will also connect to the output. Let's see whether it works. And let me publish the message. Here we go. So we were able to process the message completely through a configuration based, and both these functions were written in isolation, so they can be unit tested as well. So I'll move on to the presentation now. Back to the presentation. So these are some of the references where I'm borrowed my content from, primarily from spring.io and codelabs.solace. And that's all from my side. Hope I was able to give an overview on the message-driven microservices and how easily we can create using the Spring framework along with the Solace. Now, I will hand over the stage to the next presenter, who is going to talk about a very interesting topic, that is reactive programming. Thank you.